to the first of our panel discussions here today, planning your digitization and automation roadmap. All EMS manufacturers need to developing a clear strategy and roadmap for their digital transformation journey. This panel will discuss how to invest in the right technologies and tools to support these goals and build a cross-functional team. I'm delighted to be joined by Jeff Peabody on the end from Critical Manufacturing, Michael Ford from Aegis Corporation, Peter Bollinger from ITAC, GmbH, and Tim Burke from Arch Systems. So welcome, gentlemen. We're looking forward to a good and rigorous debate because we've got some pretty smart people on this panel today. So let's get started with, first of all, a breakdown on the digital roadmap. What technology areas does it encompass? Now, Tim, you actually were kind enough to give us a chart that we're going to look at now, which outlines some of the blocks that you believe are involved in that journey. Perhaps you can talk us through it.
Sure. So when we see, what's working across the industry in many different factors, many different scenarios, we see a couple commonalities. The first being that machine data is playing a central role in digitization, getting rich events out of machines, not just simple KPIs, but rich, nuanced detail of what's actually happening on a shop floor. Streaming that data into multiple systems, could be into the MES, could be into multiple other factory systems like an SPC system, a QMS, ERP systems, both inside and outside of the factories, a need to unify data between older equipment, maybe with PLCs, next to very smart advanced equipment at outputting files or complex traceability data, putting all of that together, and then leveraging some more advanced cloud-based systems to do advanced analytics on top of it in parallel with the standard local shop floor control, advanced shop floor control, maybe some edge-based AI or machine learning. People always talk about this. And we see all of that sort of flowing together around this streaming event architecture, unifying data from machines and keeping that rich nuance so that the consumers decide what they need to take from that to power their applications.
Well, that's quite a comprehensive list there, of course. Peter, do you agree in general that that's the way it should flow, or do you have any changes to what was described there?
Yeah, I think there's two things we need to consider, right? Of course, we need the data, right? And of course, we need to analyze it. We need to get in the factories machine learning AI capabilities. The problem is today in the cloud, if you stream all the data up, it's very expensive, right? So you have to have a way to connect to the brain to the cloud, because every day Google, Amazon, they come up with new algorithms, new technology, and now you need to build a bridge between that knowledge and get it back on the factory floor. So for my opinion, what's missing on the chart a little bit is an edge device that is able to download the AI from the cloud in the manufacturing environment and run it there. Right. Because you will not be able to run it in the cloud. There's latency problems, there's performance problems, and so on and so on. So an edge device is absolutely needed to make it work in a factory.
How receptive are manufacturers coming to accept cloud-based technologies? I mean, for a while there, they didn't want to have anything going outside the factory. I mean, are they becoming a lot more open to this?
No, that's what I said. You need the edge, right? What we want to do, and manufacturing are still resistant to go completely in the cloud. As I said, cost is one, security is another one. Right. It may be change in 5 years from now, that's still a problem. On the other hand, we cannot afford to lose the knowledge that's there. So what we should do is we should train models, we should take the knowledge from there and train models in the cloud, but then take it back with pressing a button or something like that and immediately run it on an edge device and perform it. And that's the way to go, because then you're still disconnected from the cloud. You use the best of both worlds. So you can run it in the manufacturing, you're secure, no problem. But for the training part, you use everything that's available to us in the cloud. As I said, millions of people working every day to enhance the algorithms over there, and we need to build the bridge to it.
Yes, yes. Well, I know, Michael, that you're very hot on the security issues. I'm sure you probably agree with that.
Yeah, security is one of the main things that people should be aware of today. And I think there's a marked change from the user or customer perspective as to how to build that digital roadmap. Because in a few years ago, let's say, people would go to a solution provider with a list of boxes to tick, and that would be their potential return on investment that would help them decide what solution to use. Times have changed. We need to think about security of data. We need to think about interoperability, because there is no one solution provider that can provide everything. We have many vendors of machines on the shop floor. We will have many vendors of software solutions. So analytics, as Tim described, taking those into a cloud, taking them off-site, doing them on-site. There are pros and cons. There are different things that fit different people. So I think that rather than inundating people with technical jargon, the customer, the end user, needs to build what they think is important for them.
Right.
These are the business issues that I'd like to solve, not just today's problems, but I want to have that established for some time. Because their biggest cost going forward is going to be the cost of ownership, not the cost of purchase.
Right.
So therefore, they need to have that strategy with security built in, interoperability built in, and for some of the smaller customers, they really need to pay attention to the cost of machine connections.
Right, right. Jeff, I mean, I think it's a very important point about interoperability, because you go into a lot of factories and there's a completely different mix of equipment on the production lines, and sometimes companies buy different best-in-class products. Sometimes they do it through acquisition and they acquire different types of products. But it's important that you can connect to anything, both on the machine level, but also, of course, on other software platforms. Would you agree?
Yes, absolutely. Interoperability, and I think IPC has gone a long way to create standards to facilitate that. So that is absolutely critical. One of the points that I wanted to bring up, we see a lot of companies, and this was a beautiful chart, by the way, that was brought up. But some people will see that and they're like, wow, that is complex. How do we approach that? And I like the wording of the question, because digital transformation is a roadmap, right? It's a journey. It's not that you're going to get there immediately. And one thing that we, can happen is companies will get into this, what I call analysis paralysis, where it appears so big that they don't move forward. You've got the connectivity, you've got the cloud decisions, you've got security, latency, all those questions. But really, digital transformation, all companies have gone through it. If companies have moved some of their stuff to the cloud, that was a digital transformation. If they've implemented an ERP, that was part of a digital transformation. What we like to tell our customers, and we see a lot of people who don't necessarily do this, is at the beginning, map your process from beginning to end. And when I say beginning, I mean from taking the customer order to getting products back and returning those products or getting returns from customers. And then, like these gentlemen have said, identify that value stream, what solutions you want to plug into different pieces of that.
Okay.
I'd like to add one thing to this. I think we have a job to do. We're all software vendors, right? And the chart is complex, that's correct.
Mm-hmm.
But it's like I compared with a car now, right? In a car, you have an eco mode.
Yes.
So you can switch to the eco mode and you drive eco mode. The control behind it is complex. The car looks at RPM, the car looks at gearboxes, all kinds of stuff, does decisions for you and drive it. And I think our job is that we make this complex thing that's behind it simple for the end user, and the end user can just implement his use cases with simple tools. So our job is to make this picture behind the scenes, like in a car with the eco mode, and the customer just has the button and say, I want to drive now with AI, and I want to drive with machine learning, and he defines the process which he wants to choose, and then he drives it. And I think that's our job as software companies, to hide the complexity behind and make a simple solution for the customer to implement it, because none of our customers has the expertise to do this kind of problems right now, and
very true.
they are not finding the people right now. Right? If you go off today and say, oh, I want to have a data analyst, or I want to have an expert on this topic, you pay a fortune, number one, and number two, you will not find it.
Well, that kind of brings me to my second question, which is what are the skills that are needed to achieve this digital transformation? I mean, is the production manager in the factory, is he got to be able to interpret this data and make decisions, or is it really going to be, they're going to have to start hiring data analysts to back this up?
So I wanted to reinforce and echo what was just said. I think at the end of the day, one of the opportunities in Industry 4.0 is trying to find off-the-shelf solutions for analytics that may be complex internally, but are simple and explainable to people on the factory floor in terms of what they benefit them. And so talking about what skills are needed, one is to build them, one is also to use them. We see a lot of need for factories to understand data and like what you can do with it, how it can power it, but how it's relevant to your job and your particular function. And so to the point of mapping your process end to end, there would be a different answer for, could data help you do receiving? Could it help you do control? Could it help you do quality? In what ways? And what are the examples specifically of not the technologies or the algorithms or any of that, but what do you see? How does it help you? How does it impact you? And then is that available to you? Could you actually choose to buy or build that if you wanted to? Or are you going to get stuck trying to implement it because you don't have the different skills needed to build it, but you do know how to use it?
Yeah, it's really tempting for companies to just want to grab the low-hanging fruit and say, oh, we have this problem, we want to address it with something. But the reason I think we're all mentioning, map your value stream, is because you've got to create this vision, right? You've got to have the whole vision, and then maybe you grab low-hanging fruit. But if you start by just grabbing that low-hanging fruit, you're going to end up with what they called silos of automation, some time ago. So.
Yeah, we've got to remember that customers are customers. They're not the technical experts that we are. But they do demand information. They want to know what's going on. And that is really to inspire confidence in the solutions that we all provide, because they know that this is going to make or break their operations. And some simple mistakes, some poor choices can lead to all kinds of problems happening in the future. So they need that level of confidence. To go in there and start explaining everything at a highly technical level, they kind of gain confidence and then they get confused. Mm-hmm. So it really is a matter of understanding the customer's need in terms of what are they really looking for as part of their business. Whether that is performance, some kind of connectivity, the cost, and the security aspect. And then really being able to meet that need and give them the assurance. This is not how it's going to work tomorrow, because that's a given. It should work when you first install it. But also this is how you're going to go in the next 2, 3, 5, 10 years. This is kind of the ecosystem or the structure in which that value is going to grow over time.
I think I want to add something to what the colleague said here. And I think I would start a little bit different, right? I would not say what expertise is needed. I would say, what do we have?
Right.
So what do we have in manufacturing? A lot of expertise on the process, a lot of knowledge about things that are going on. So now, again, our job is that we're building tools that enable these guys to get this knowledge inside a piece of software that does a job for them.
Yeah, so essentially what you've got to do is go and do a technology audit, first of all, of the customer to see what he's got, and then act as almost like a consultant to suggest this is the way that he could enhance that or optimize it.
I would even go a step further, right? Because the mix that we're having, right, in manufacturing, right, we have old, new, and so on, right? What we need to do is we have to deliver something that can adapt to it quickly, and that's our job in the installation. Mm-hmm. But then, like with the car, same analogy, we have a driver, and we tell the driver, you just press that one button. Don't worry about the rest, right? And that's our job, right? So we have to make sure that this technology, which is available, is so canned in a solution that they don't see it. Mm. And they just know, okay, I'm an expert on my process. I have a certain problem to fix, right? And then I know which button I have to press. And I don't need a special training on AI. I not need to know about machine learning, and definitely not to need to know about IoT technologies that are needed for that, because that's our job, right? But that's the way we need to drive it, right? So they have the knowledge, and we have to find a way to get that knowledge in the software, but in a very easy way, so they not need to have the experts. Otherwise, we will fail. The next thing I think that we should do is standardization of the algorithms and AI solutions, because we have an SMD process, right? And certain things are the same in all the factories. Mm-hmm. So now we have to look for algorithms and improvements in machine learning that everybody can use, right? And when we standardize that, the only thing we need to do is we deploy it and it runs, right? And that's the way to go.
I don't disagree. However, I think there are two different perspectives. One is to automate what we already know, what we already do, make it better, faster, stronger, put bionics into our manufacturing, that's fine. But I think we're also learning a lot. I mean, Tim's technology especially. You can start to analyze things and you learn. You learn about problems that you didn't know you had, solutions that you need to look into in a lot more detail. This is where the kind of sharing of data and ecosystem approach works, because things may appear to be symptoms, and if you spend too much effort to solve them, you end up losing the bigger picture of what is actually the cause. And the causes can sometimes be something so simple that people didn't even recognize it when they saw it. Right. So as we move forward, I think our role as software providers is not just to focus on automating what is currently happening, but actually preparing manufacturing for the future and understanding all of the different ways that we can automate using software and achieve that Industry 4.0.
Right, okay. So let's boil it down to its simplest use case. How does a tier 4 manufacturer with one line benefit from this?
Poor tier 4 manufacturer. I would say there is a very easy solution. And Tim and I, for example, we work with the IPC CFX, and you mentioned IPC standards. We've had examples where people have been able to connect to CFX qualified machines, able to take the data, and a student, for example, making some kind of dashboard within, a couple of weeks. So they are not faced with the sticker shock of, first of all, starting with a solution from one of the big guys, and then thinking, okay, well, that's quite reasonable for the ROI, and then thinking, oh, how am I going to connect to all of these different machines that may need customization or middleware and that kind of stuff. Mm-hmm. So for a tier 4, it's got to be almost free, and it's got to be something that shows them how to create value from data. Because, people don't read the brochures. They don't believe it until they see it for themselves. Right. So having an encouragement to take that first step, to create that value, to understand this is not a symptom, this is a symptom, this is not a problem, the problem lies somewhere else. That is how they go forward.
Free is a very interesting word, isn't it?
Yes, indeed.
So,
free, actually.
So anyway, Tim, I mean, your particular company does a lot of stuff with tier 1s, where they're soaking up data from across the world, across multiple different platforms. How do tier 3s and tier 4 manufacturers benefit from the data intelligence that you would get from one of these big tier 1s?
Yeah, so it's a very good question. And I think the way I would answer would echo some of the things that have been said already, which is if the data is shared and embedded in solutions or models, as was said, or solutions to problems that are learned, for example, like you needed to look at, say, 500 lines to know, like, this is how you solve this problem. But once you know that, it's the same solution that you would put into a tier 4 or a tier 3 if you have 2 lines or 1 line. Now the question is that solution available to the tier 3s or the tier 4s to purchase or implement, or is it still locked up only with the tier 1s? And so I think one opportunity we have with more data sharing, with more ecosystem approaches, is the learnings that are done on the 500 lines, the 1,000 lines, like the giant tier 1s, get translated down to the tier 3s, tier 4s, not by people moving from company to company and bringing their best practice, that's one thing, but also by having standard solutions that this is what is used on every line in the tier 1. You can also use it on your line if you want. It will work the same, will solve the same problem for you, but it is finally available. It's not like it's only available with a giant implementation, a giant price tag, which needs 500 lines before it makes sense. You can get the same thing pre-built for your 1 or 2 lines, if that makes sense.
But I mean, are the tier 1s going to be happy with you giving up that information? Surely that's a USP for them, you would have thought.
So I think everyone has a perspective on this question.
Yeah. I think, as I said, there's 2 things, right? We have to distinguish, right? Of course, there's protection of intellectual property, right? And the tier 1s are eager to do that. On the other hand, we have also a job. Some of the things, we can also come with standards, right? And then offer the standards to others, right? For example, we have a cooperation with a company that is willing to share the knowledge with others, right? And that's okay. So we do that, right? So we try it out in their factory, and then when we get something working, as he said, standardization is then the word, right? So we need to standardize it, and then they can benefit from the standards we have. Of course, we can do that, but as you said, there will be limits, right? Because not everything that the tier 1 are doing will be available to everybody, right? But a few things might be available to others too. Sure.
And your comment was right on, right? These tier one companies are very protective of the IP, and they should be. One of the benefits I think that these tier four companies get is through buying a commercial product, they're actually getting a product that has know-how from a very broad spectrum of customers. So things that maybe they're not thinking of, but that somebody else has, and it's been put in standard product. But the question on tier four manufacturers is really an issue of scale, right? And typically what we see is the first one takes most of the resources, most of the thought, most of the effort, and then to duplicate that, gets substantially less expensive. So really that's what they're trying to overcome. But by buying a commercial product that has a lot of capability already implemented in it, they get the same benefit.
Yeah, I would go along with that and say their main problem is actually scale because they have so many operations with so many different types of machines, so many different people with so many ideas, experiences, history. They all start arguing with each other and you end up where nobody is actually the real owner of the information. So when we come along with solutions, as Peter was saying, we need to bring that know-how in, we need to provide that kind of solution that is turn it on and off it goes. So in that kind of level of customer, education is done in a slightly different way as we would do to a lower tier customer. But really being able to have the buy-in for people to understand that this is how we automate what we have, but this is how we use data to create further value. It can be an open-ended adventure doing that, and people will learn different things and start to align across the organization as time goes on. Because if you don't do that, the big organizations will fall out with each other. I've seen it happen, where one company says, we don't do it that way, you make a different product for a different market, we're not going to buy that system, we don't really respect it. But if you can provide a top layer, as with the analytics that is actually showing them day by day advantages and values, they begin to think, well, okay, maybe we want to go along with this and maybe we'll align because we know it's bringing us benefit. So the politics involved are very, very strong. And once you get that together, it can be extremely valuable.
Yeah, I think there's a whole range of things, as you mentioned there. I mean, and even across the different geographies. For example, Tim, I mean, you're gathering information from factories that are in Asia, where the humidity and temperature is completely different in the factory, and everything behaves differently, and trying to match it up with products getting made here in the United States or in other parts of the world.
Yeah, so these are all correct statements. The large tier ones are also just a collection of many factories put together, possibly through acquisitions. There are many humans involved. Whenever there are humans involved, there are politics involved. And I would say as well, even the tier ones, some of the ones that we work with, they are also looking for ideas. Okay, well, how should we do this new data thing? Like what can actually help us? Sure, we can collect it, we could throw a bunch of money at it, but what is the ROI, what's the opportunity? And so one area we found a lot of success is providing expertise into that equation, not on how to run the factory. We do not know how to run your factory better than you do, but we do understand data, we understand how to analyze things, and we can talk the language with your experts, your people who actually understand your processes, and take the best of both worlds and say, okay, what do you really, if you were to solve this problem for real in your factory today, what would you do? And then try to translate that. Is there a standard approach we could build into software that works in a similar way using your expertise? And that together can help the tier one. And in the case where it makes sense to share, where it's not IP protected, it can also make sense to share more broadly and also then trickle down to the tier 2, tier 3, and tier 4 in ways that are now just standard off-the-shelf products, but could be very complicated, but as was said, simple to use.
I think I would drive it even one step further and say, okay, we need to look at manufacturing and say where is pain points and where can we save cost and improve performance, right? Number one. When we figure that out, we say, okay, where's an area where we should focus on, right, and help with our expertise and say, okay, this is a big area. For example, one area today is testing, right? It doesn't add anything to the process, right? If the product will all be good, we don't need testing at all, right? So that's maybe an area to focus on and say, okay, how can we reduce the number of testing, which at the end helps the customer to save cost and people, right? Well, and then our job is then, as he said, consulting and try to find solutions to reduce the effort of test inside manufacturing, right? And then they save cost, and then we have a problem solved that we can standardize and then maybe give to others. But clearly, right, a big company benefits more than a small one from that kind of stuff. Sure.
Right. But going back to your question of test there, Peter, I mean, test is very much the eyes and ears of on the line, and the trend at the moment seems to be adding more test areas rather than less on the line, because at the end of the day, the earlier you can catch the defect before you solder it to the board, then the more money you're going to save.
Right, but you have to look at it different, right? Right now we have a tester, so tester does in his station whatever. Data, right? What the tester doesn't do. The tester doesn't look at all the process data around. It let's look at the test, right? And that's, I think, what we need to change. So we need to look at all the data that are available to us from every process that we have in manufacturing, analyze the data, and then do predictions and say, okay, when we have this data there, and that data there, the sport will never fail in test, right? And that's the way to do it, right? So we have to go out of the silo and say, this is a tester, right? We have to go the whole process.
At the entire environment.
Entire environment, and then do predictions. Right. And that's the whole idea of machine learning, right? Or artificial intelligence is to go in and say, let's look at all kinds of stuff which a human can't do in a short period of time, right? And let the computer look at all the data, make sense out of it, right? And then drive a decision for us.
Okay.
This is a really interesting area, because I agree that testing is a complete waste of money because you never plan to make defects. So great, end of story. But it's not, because testers used to be there to filter out defective products. They're not actually used for that anymore. They're there to gather the data for analysis, because you get more data from a product that passes than a product that fails. So that you can understand then what are the unique set of circumstances that's occurring on this product. Then that comes from context. So machine learning is maybe one machine learning by itself, getting operator feedback. Then you connect 2 or 3 machines together. There's a limit on how many machines you can connect. So then you start jumping up to analytic systems that take the full context of the factory into account, so that if anything goes toward a defect, then you can understand, what is my root cause of that? What were the unique set of conditions? So then somebody that's selling a testing machine is not actually a tester anymore. They should rebrand and rename them, really, because it's actually a quality confirmation
system,
so that you've then got not just factory level quality, but statistically it's shown that then there is better market reliability. And that's what really matters to the manufacturers, because what happens in manufacturing, it may be painful, but you can fix it. What happens in the market, and you've upset your customers.
Right. Okay, we're running out of time, guys, so I'm going to give the last word to Jeff at the end there.
Well, this is an interesting discussion, and I've often thought that testers are kind of like driving a car blindfolded, right? When you hit the curb, then you make the correction, right? And the ideal thing is through analytics during the process to actually catch those things before they fail the product, right? So you're not finding the issue and then going back and researching it. So that's kind of the holy grail. But one last point I wanted to add is we've addressed this digital transformation from the technology side, and that is absolutely key. But one of the things that must be considered is this is not an IT project, it's not a data project, it's a culture change for the company. Right. And companies that fail to kind of promote this and generate the excitement, you can have a fantastic technology solution, but if the operators out on the floor aren't adopting it, then it's going to be unsuccessful. So think of it, my word to executives is to think of this as a cultural change and not necessarily an IT project. So
absolutely, and this debate is going to go on for a long time to come. So I think it's been a fantastic debate today, guys. It was as I expected it would be. And I want to thank you all definitely for coming in and joining us. And if you at home are interested more in this topic, then please look up our eSmart Factory Conference, which we are going to be holding in, it's on 8th of May in Nuremberg, Germany, where we'll be exploring this topic and a lot more other areas around the digitization and transformation, automation journey. But for now, I want to thank my guests today for joining me, and I want to thank you for watching.
Why do something 3 times when you can do it only once? Using N1 Pass technology, BTU's new Profile Tracer is a next-generation thermal profiling tool, providing real-time data acquisition for oven optimization. It identifies inconsistencies due to temperature variables at both the product level and the heat source. Profile Tracer measures dual temperature locations as well as vibration, all in one pass, giving you time to attend the more important things in life.
Ko-Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionized the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Ko-Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.